Question 20 is coming from transformations. The diagram shows three shapes A, B, and C on a 1 centimeter squared grid. 1 centimeter squared grid, it means this one is 1 centimeter and this one is 1 centimeter. So when you get 1 centimeter times 1 centimeter, you get 1 centimeter what? Squared. Now, part A, on the grid, draw the image of shape A after a rotation of 90 degrees clockwise, center 0, 3. So identify the center 0, 3. It is here. Then you can use your protractor, but here I have you can use the tracing paper, but here I have the protractor. So I can put my protractor there. Okay. And then we are rotating 90 degrees clockwise. So clockwise is here. Okay. You move like this. Now, this simply implies that I'm going to get this, put it like this. Okay. In fact, let me put it here. Then 90 is here. Okay. So if this one goes here, 2 squares, then I'll go 2 squares on this 90. See that? So that means I'll get this point here. Here. Then we can proceed to this other one here. 90, remember this one is a diagonal in 2. So we go a diagonal in 2. Diagonal in 2, it goes like that. So you can even see the line of 90. We are going to have a diagonal in 2. It will be here. So I will mark this point here. You see? And that is that. So I'll take this off. And then I join. So just join this point here to this one here and to this one here. If you want, you can shade. I can shade this one. And then I label it. This one, if they tell you to label it with a letter, that is what you use. But this is part A. So I'll put here part A. And then B, describe fully the single transformation that maps shape A onto shape B. I've always told people that look at the number of marks that are allocated on such a question of description. If it is 2 marks, then you think about reflection. Okay? You think about reflection and translation. So if it is reflection, you tell us reflection in which mirror line, you give the equation of the line. If it is translation, you say translation by which vector, you give the vector. Those are the 2 marks. But then if it comes to 3 marks, you think about rotation. You have to give the direction and the angle. Maybe rotation through 90 degrees clockwise, then the center of rotation. Let's say at center dash. Those will be the 3 marks. And then the other one can be enlargement. Okay? Enlargement. You tell us that it is enlargement. Then what is the scale factor of enlargement? Then what is the center of enlargement? You see that? Now, let's look at shape A onto shape B. A onto B, it is 2 marks. You can easily see that these 2 are looking the same. So they just shifted this A 2 units here and then 1 unit down. Like this point here came here. So we have 1 and then, 2 units here. Pardon me here. So these are 2 units and then 1 unit down. So we shall say this is translation by vector. Since we are going to the right, and when you look at X, it is positive going to the right, then negative going this way. Y is positive going up, okay? And then negative going down. So we are therefore going to right the vector as 2, then -1. Then Roman 2, shape A onto C. For enlargement, for reflection, translation, and rotation, the object and the image are congruent. They are the same size, okay? But for enlargement, you will see that one of them is bigger than the other. So you can see that if you are translating, if you are transforming this shape A onto C, C is already bigger than A, so that has to be enlargement. So we shall say this is enlargement by, you have to give us the scale factor. The scale factor so and so, then center. Which one is the center? You give us that coordinate, the coordinates of the center. So what do we do in order to find the center? Draw lines through object points and corresponding image points. Where they meet, where these lines meet, is the center of enlargement. So we are now going to draw the lines in here. Now this line here is a diagonal in 3. So it goes like that, diagonal in 3 like that. Okay. So a diagonal in 3. I'll draw that like that. Okay. Then another one. Of course, this one here connects to this and that. So you find that they meet here. Okay. So that center is 5 as the x coordinate, then y as 3. So the center is 5, 3. 5, 3. Then we need to get the scale factor of enlargement. You need to get, let me actually write it here. Scale factor. Scale factor of enlargement is equal to the image side length divided by the object side length, or it can be equal to the image distance from the center of enlargement divided by the object distance from center of enlargement. So what do I mean? Image side length over object side length. So look at this side here. These are 2 units. This is 1, the corresponding one. So that is 2 over 1. That means the scale factor is 2. And it is 2 positive because the scale factor can be a negative. Okay? If the object and the image are on the same side of the center of enlargement, then the scale factor is positive. So the center is here. The object is this way on the left, and also the image on the left. So they are on the same side of the center of enlargement. So therefore, the scale factor is positive. But if this one was here, and then the image is this other side, and they are on different sides, on opposite sides, then the center of enlargement would be a negative. Okay. Then how about if we use image distance from the center? Look at this point here, this one. When you look at here, the distance is 3 units. That is the object distance, so 3 units. The corresponding point here, the corresponding image point on C is this one here. So when you check its distance from here, these are 6 units. So 6 over 3, you get a 2. You see? But it is easier to use image side length divided by object side length. Even here, I can use this is 4, then divide by 2. You get the same answer all throughout. The scale factor of enlargement is the same for all of them because it is what you multiply into the lengths of the object then to get the image. Calculate the size, part C, calculate the size of the smallest angle in triangle C. Now, when you check triangle C, here, the size of the smallest angle, that is the one which corresponds to the smallest side. So the smallest side is this one. So the angle that is opposite to it is this one here. You see? Then the angle which is here corresponds. Since this one is big, then the angle here will also be bigger than this angle here. Okay? So we are going to have that triangle here. Let me draw it perfectly. It's a right angled triangle, and the angle we are looking for is this one here. We can see that up here, the height is 2 units, and this is 4. So the opposite is 2, the adjacent is 4. So using SOHCAHTOA, remember we use SOHCAHTOA when we have a right angled triangle. So using SOHCAHTOA, so this is the opposite and then the adjacent, so that will be the TOA. So tan of theta is equal to 2 out of 4, and therefore theta shall be equal to the arctan. By the way, this one belongs to this. So, but you're not supposed to write this one. Anyway, I'm just explaining. I was just explaining how you get the scale factor. Okay. So arctan of 2 out of 4 is actually a half. So just get your calculator, but make sure that it is in degrees. Okay. So my calculator here is already in degrees. Arctan over half, which is 0.5. That is 26.6 to 1 decimal place. 26.6, 1 decimal place. Remember, we give angles in degrees to 1 decimal place.